Sir Isaac Newton was a scientist who lived over 300 years ago in the country of England. Legend has it that Newton was inspired by watching an apple fall from a tree and began his study of gravity and motion. From this study, Newton developed his now famous 3 laws of motion.
Newton's first law says that an object at rest tends to stay at rest, while an object in motion tends to stay in motion. Both will hold true until an outside force acts upon them. In this first clip, you will see the bowling ball at rest according to Newton's first law. This bowling ball will stay right here at rest forever or until it is moved by an outside force. This outside force, like any force, is a push or a pull. The bowling ball will be set into motion by a pushing force
or pulling force. Once the ball is in motion, according to Newton, the ball will stay in motion until it is acted on by an outside force. In this case, the outside force is provided by a brick wall. A bowling ball is very useful in showing Newton's laws of motion because on smooth surfaces, the friction is very low. Friction is a force that opposes motion.
Newton's second law is a mathematical equation. It says that force is equal to mass times acceleration, and it is written simply as F equals m times a. When F represents force, m represents mass, and a represents acceleration. If we ignore friction or minimize it by using a smooth surface and a bowling ball, we can calculate using Newton's second law the force needed to move an object, the mass of the object, or the acceleration of the object. If we know the other two, in this activity we can determine the force needed to accelerate the bowling ball. The force is provided by a person pushing the ball. In order to calculate this force, we must determine the mass of the bowling ball. The mass of the bowling ball is 5.4 kilograms. Next, we must determine the acceleration of the bowling ball. We do this with our motion detector and our laptop computer. We measure our bowling ball's beginning acceleration at 2.1 meters per second squared. If we insert these values into Newton's second law equation, it looks like this.
Now we're solved for F, or the force.
According to Newton's second law, we applied a force of 11.3 kilograms meters per second squared, or newtons.
Newton's third law says for every action there is an equal and opposite reaction that takes place. This law can be shown using an instrument called Newton's cradle. As one ball is pulled out and allowed to return, striking the other balls, the end ball on the opposite side moves out in response. If 2 balls are put in motion on one side, 2 balls move out in response. Likewise, 3 balls in, 3 balls out.
You have watched an explanation of Newton's 3 laws of motion. We see Sir Isaac Newton's laws in action every day in the world around us. So next time you see an object at rest or an object in motion, take a minute to think about and appreciate the work of Sir Isaac Newton.
That's our fault.